Hey, what's happening, guys? I don't know if you remember or not, but back in September of 2020, I put together this heavy-duty prototype board that you see me putting together here, and this is just a replay of that old video. And you guys seem to like it, and I got a few requests. People wanted me to add things to it, like a clock generator, voltage regulator, etc. So that's what we're going to do today. We're going to try and see if we can't make something that was as good as the original, but perhaps a little bit cooler. So what I've got for you here is a new idea in the PC prototype board, and we're going to make it like the first one, a little bit thicker on the fiberglass, a little bit heavier on the copper. But the neat things that we're adding to this board here include a 5-volt regulator. Here's our clock generator, which is basically just a 555 timer. And I think that'll add some interest to it. What do you think? Let me know down below. So here's the layout I've come up with. And for the most part, it's good. There's one problem with it, which you'll probably see. I'm not going to point it out. Let's see if you can figure it out. As soon as I saw the boards, I could see the problem. But anyway, so this is it. This is what it looks like. And let's here, we'll give you the old 3D viewer. Yeah, it's going to look a little something like that. So if you look down here, let me get my graphics pad out again. Okay. So here's we'll have our power input, put up like 12 volts in it. What's this? A surface mount power regulator? Yeah, I was feeling saucy. So we'll do a little surface mount. There is our 555 for our clock generator. We're going to have a power switch here, an indicator here, and here's our voltage divider and our capacitor for the 555 timer. So you can put in whatever you want here and control your own clock generation. I think that's pretty cool. Nothing really on the back. Okay. Pretty cool. So this video is sponsored by PCBWay, and I want you to notice here, holiday notice, Spring Festival 2023 is coming. So they are going to be closed from January 20th to the 23rd. That begins the Lunar New Year. And it's going to end January 28th. So for that entire week, nothing is going to go on. Just make sure you realize that. So to get these boards thicker and with more copper, we come down here and do our PCB quick order. We add our Gerber file. Add the Gerber. There we go. I just remember which one this is. Proto Board. Here we go. Sometimes it draws it. Sometimes you get this. This doesn't matter. So there's only one design. It's 160 by 80. I'm only ordering 5 of them, 2 layers. We're going to make it out of FR4. But we're going to crank it up to a 2.0 thickness, which, adds a little bit of thunk to it. We'll go black, we'll go white, no edge connectors. The plain silver lead finish is fine. We don't need gold. But we'll click this box here just in case they have some extra gold and they want to use it. And then we will up our copper to 2 ounces. So that does increase the price significantly, mostly because we are over the 100 millimeter cutoff here. But I think it's going to be a cool board. So it's the 1st of January. Let's wait a week and see what happens. All right, so I got the boards back, and PCBWay always does a super nice job. Everything looks good except my spacing. So, you know, here's a standard 8-pin dip. It should bridge that gap, and, well, it's not going to. So for Rev 2, we're going to have to shrink all this stuff together. But we're going to get started and do up our electronics, make sure everything is copacetic here. And I think that'll be pretty cool. So, where shall we start? Probably with that resistor, which I should have marked, huh? So this resistor, if you could see the track there, goes to the power indicator LED. So it's a current limiting resistor, just for the LED. And in this case, we're going to use a 1K, because the that LED is going to be right here, and it's going to be in your face when you're trying to work. And we don't need anything to be super bright. We just need an indicator that there is power applied to the board. That's it. So we'll get that guy soldered in here. I want to thank all you guys who sent me birthday wishes. That was very cool. Whenever I stick any sort of plier into my tool cup, they will instantly bury themselves, causing me nothing but pain. All right, next up we'll do the power switch. Should be relatively easy, right? I wonder which one of these is. There we go. Well, I don't know if that's better or worse. Ay, caramba. What the? Now it's too dark for me to solder. Let's turn this one back on. I apologize. Need to figure out a better way to do this. I need some kind of diffuser for my lights, I think. I think that would do the ticket pretty nice. Hey, I want to turn you guys on to a great YouTube channel. I mean, if you're watching this channel, you're obviously into electronics, so check out IMSA guy. IMSAI. Like the old computer, yes. This guy's pretty cool. All right, let's we'll put in our power indicator LED. I've been watching him for about a month now. And what got me started watching him was when I started looking up information on the Tiny SA. He had a whole bunch of it. He says in his video he's some kind of a optical engineer. He's retired, but this dude, like an RF engineer, if you ask me, he knows quite a bit about RF, which is absolutely my weakness. I admit that 100%, and no shame. I don't like RF. My motto has always been, weird stuff happens at high frequencies. You know, electrons start moving where they like to transfer. Things start doing inductance that was never there at lower frequencies. So these are two 10 microfarad capacitors we're putting in here. They seem awfully big, like reservoir caps for what we're using them for, which is on the voltage regulator. Now, about my mistakes. I've had offers from a couple of you guys to go over my designs, especially from my Bud Berry. Here's the thing. That sounds like a great idea,
But I'm not that organized. Right now, it is Saturday, January 14th, and it is 9:24 a.m., and I decided I was going to do this video about 10 minutes ago. So, I had no way of knowing when I was going to do it. It's just kind of how I work these days. After 8 years on YouTube, it's hard to come up with ideas. Coming up with ideas is probably the hardest thing about having a channel this long, is coming up with new ideas. So when something strikes me, I run with it. Like when I drew this board up, I have no idea when I drew it up. I could look it up, but it wasn't that long ago, a couple weeks ago. That looked fine to me. So, I don't know. All right. One moment, please. All right, let's do our surface mount component next. And for that, I got these Bridgold AMS 1117-5 regulators. They've got an output of 1.4 amps, which should be, you know, well, more than anything you'd need for a project like this. And they can take 30 volts. You don't want to be putting 30 volts into this. Why? Glad you asked. There's only one thing that you can do with excess voltage. You can turn it into heat. That's really it. So, if you have excess voltage, it's going to turn into heat. A little bit of flux. And then I'm going to lightly tin this top pad here. Now I'm going to use these locking pliers, so hopefully I don't launch this into low Earth orbit. And I did. Is this it? Luckily I found it. Unbelievable. Different pliers. Yeah, I don't know where they're at. So, let's try this. I want to lock this here. Then what I want to do, remount this, move that into place, and now we go in there and have a nice close look. Everything is sitting pretty. So let's see if we can get you a better view here. All right. Now I'm going to add more of Uncle Rob's Magic Solder Flux. And with the clean iron, you're going to solder those legs down. All right. I think we've got a pretty decent joint. Let me just hit this a little bit here. Make sure we're all nice and connected. Oh, and of course I would bump the doggone camera, because that's how my life goes. All right. Next up, get the 555 timer ready by putting it into my custom-made leg straightener. No, I don't know where you can get one. That was made for me in Canada. Little blue tack to hold it in place. And we shall commence the soldering. Get our two opposite corners in place. Then we can remove the blue tack. Chip looks good, so we'll finish soldering it in. Some of you are saying, well, if you screwed up the measurements on the board, then why are you even bothering to do this solder? Well, because I want to make sure the electronics work. Yeah, it's going to have a rev too, but if there's another mistake, I'd like to catch it now. At least that's my story, and I'm sticking to it. All right. Next up, we'll put in the jack. These can be not so much a problem, but they can be a little more difficult to solder than other things because you have a really large area that you need to cover. So what I like to do is I'll take my soldering iron, just bump it up with 360. What that does is that decreases our dwell time, how long we're holding heat on the component. The lower your dwell time, yeah, the better off you're going to be. Good. Then you always want to take the blue tack off as quickly as possible so that it don't get in there, get all sticky on you. All right, let's do the next one. I'm putting a little pressure on that leg, but I'm making sure that I'm also touching. Oh, that didn't go anywhere, did it? There we go. Then I'm also touching the pad. Not that there's much pad in these, but you know. Like I said, these can take quite a bit of solder. That looks good to me, though. Okay, so now we got to do this part. And for that, my most hated. The reason I hate these, I mean, I don't hate the male-female headers. I use them all the time. It's just really hard to get a nice, neat edge on them. Okay. Bring them in. We'll do this one first. The order when I'm doing these, yeah, it really doesn't matter. Good, that looks pretty vertical. Hit it again. Man, I tell you, I woke up with a nasty headache this morning, guys. Stress related, I'm sure. Blake called me last night. He's home for the weekend. And told me that Jedi, his dog of 16 years at his mom's house, has to be put down today. That's hard. That's really hard. And it's especially hard on him. Over the last year since 2018, our family has pretty much been wiped off the face of the earth. I mean, they're all older and everybody dies. But yeah, he grew up his entire childhood with this big family. Now there's like no one left. So he is having a really, really rough time with it. But he'll be okay. I have faith in him. One more to do. That is our clock pin. This is going to be fun. Because I just want one. I don't think I've ever tried to get one. We'll see how it goes. Grab our old friend, the blue tack. Man. This stuff does not want to come apart. Which I guess is good. That's why it doesn't stick to your walls and all that. But man, it's all over my fingers. So yeah, Blake will be down a little bit. It's 9:41 now. He'll probably be down around 10:30. And I'm sure that he will be spending some time with Dogley today. And I believe that that ends our soldering for this. Yay! So, we'll bring in power here to the jack. The regulator should put 5 volts here, 5 volts to this rail, and, you know, ground to that rail. So, let me get set up and we'll check it out. Okay, power supply is set up for 9 volts at 100 milliamps. Got the meter in here so you guys can see what's up. Turn the output on there. Plug in the board. And we'll see what happens. Great. No volts at all. There's 9 volts going over there. So that's our ground. Anything in the pin 8? No. What did I do wrong? Humbug. Let's see if there's anything coming into the regulator. One moment. You know, somebody posted a comment the other day that said, "You're not as smart as you think you are." Well, sir, you have no idea how smart I think I am. I actually think I'm quite as stupid. Because I forgot to turn the switch on. So, there we go. Oh, you know, sometimes I wonder why I get out of bed in the morning. But it's working. Oh, let's hook up our 555. All right. So there's a 1K. There's a 1K. And there's a 22 puff. Let's hook up the oscilloscope. Need a ground reference. What am I going to do for a ground reference? Yeah. Guess I can just stick one of these in here and see what kind of contact it makes. Not a good one. Power it up. And that's interesting. We got a really strange mark space ratio. 673.9 kilohertz. Let's do the math and see if that's right. I get 218 kilohertz, so I am not sure why I'm getting this odd reading, but everything's working. That might need a buffer on it for some reason. I'm not quite sure. But it's good. For today, everything worked. That's really all you can ask, right? All right, guys, I hope you enjoyed this. If you did, give me a thumbs up. Feel free to comment, share, and don't forget to subscribe. Big thanks to PCBWay for sponsoring the video. And big thanks to you guys for watching. That's it. I'm out. Peace.